Okay, hello everyone, good morning. Am I audible? Okay. Good morning to all. Good morning. Please maintain some distance. Okay. And also please wear the mask. તમે પાછા બેસ પાસે બેઠા. Okay. Okay. So let's start the session. In the last lecture, we had discussed this concept that is a spanning tree. For any of the graph, we can create as a tree form. Okay, we can convert this graph into the tree. It should be connected graph, and all the vertex should be included in the tree. Okay, means it is a subgraph, and all the vertex should be included in this graph. Okay, so that is known as a spanning tree. Here you have to just remove some edges from the graph. Okay, and make this connected situation. Okay, which involves some cycle, circuit, and so on, and just remove all the cycle, okay, all the circuit from the graph, and consider as a one of the tree. As we know that definition of tree is a connected graph without any cycle. So in this first graph G, that is our given graph, and you have to make this graph into the tree. Okay, so how we can make this graph into the tree? So for that you have to remove the circuit, okay, from this graph, and for removing the circuit, we'll remove the edges. Okay, we'll delete the edges. We'll consider all the vertex as it is. ठीक है, will not any single vertex. सभी vertex को आपको as it is रखना है. ठीक है, and just remove the edges in such a way that all the vertex should be connected. Okay, all the seven vertex are given that all the vertex should be connected that, and after you just verify this graph, okay, there should be no any circuit. Okay, you can create between any two vertex. So that is, this procedure is known as a spanning tree. Okay, this graph is known as a spanning tree of this graph. Okay, here this seven vertex are there and nine edges. Okay, and here this create one of the cycle. Okay, between these three vertex that create one of the cycle, that is also create one of the cycle. So just remove such edges. Okay, and just open it. Okay, that create a close, and just remove the one of the edges from that and consider as open one. So I remove this edges from this one, and after I remove this one, okay, and I remove this edge. So now this all vertex are connected. Okay, and that is now look like a tree. Okay, there is no any circuit is that, all the vertex are connected. Okay, so that T is known as a spanning tree of the graph G. Okay, that is a definition that we discussed in the last lecture. And there is one notice that a graph may have many spanning trees. Okay, that is not a unique graph always. Okay, that is not a unique answer. You just change the edges. Okay, you will get a different shape in place of that. Clear? Is it not compulsory that you have to delete this edges only? You can remove this edges also, this edges also. Clear? As per the this edges, you can modify the graph. Clear? So that is not always a unique answer. You can create a different graph of the spanning tree of this. And then after we discuss this formula, that is a circuit rank. Clear? And by using this, you will get ideas how many edges you have to delete. Okay? By using this answer, you will get one of the answer. Okay, and that answer reflect that how many edges you have to delete to make any graph as a tree. ठीक है, उसमें से आपको कितनी एज डिलीट करनी पड़ेगी टू मेक दिस गिवन ग्राफ एज अ ट्री. Clear? So that formula is known as a circuit rank. Clear? In this formula, we have the data is that m minus n plus 1. Okay, m means number of edges of the graph, n means the total vertex. Okay, total edges and total vertex. Just put it there. Okay, and find the answer. So here in this example, we have 7 vertex and 9 edges. Okay, you can calculate also, check it. There are 7 vertex in this graph G and 9 edges. Okay, and just replace that m minus n plus 1. So 9 minus 7 plus 1, you will get a 3. So here we delete a 3 edges to make this given graph as a tree. ठीक है, हमने कितनी delete की? we have to delete, we have to remove 3 edges to make this given graph as a tree. Clear? So this 3 means you have to delete 3 edges. Okay, you cannot delete 2 edges, you cannot delete 4 edges, but you have to delete only 3 edges to make this given graph as a tree. Clear? If you consider 4 edges in place of 3, this graph becomes disconnect. Clear? If you consider 2 edges in place of 3, okay, if you remove only 2 edges in place of 3, this graph involve one of the circuit. Clear? So just delete 3 edges. That is a perfect answer. You cannot modify this answer. You cannot surplus, minus, and so on. Just consider only this answer and just remove these edges from the graph, and you can convert this graph as a tree. Clear? So that formula we had discussed in the last lecture, and then after one of this example, and we discussed this 3 to 4 example in the last lecture. There are some graphs is given that, okay, and you have to find out its spanning tree. That exercise already we done it in the last lecture. Okay, there is one of the graph is that you have to first check its circuit rank. Clear? Find the number of edges, number of vertex, find the circuit rank, and then after convert this shape as a tree. Clear? Which all the vertex should be included there and no any cycle should be there. Clear? वैसे आपको number of edges delete करनी है by using the answer of circuit rank. Clear? And it is not always a unique answer. You will get a different graph in place of that. Clear? There are lots of answer. It's possible for this graph. Clear? It is not always a unique answer. Okay? Then after this example we had discussed. Clear? This both example we have done it in the last lecture. Then after this 3 graph also we have done it. Okay, that is this exercise also we have completed. Okay, and that for given as a homework. So you can practice some more example. 6 to 7 graphs is given in this slide also. Clear? You can add some more graph. Any arbitrary graph you can create that. Okay, and then after check its circuit rank and find as a tree form. Clear? That's very easy, not a difficult procedure. Clear? कोई भी आप ग्राफ बना सकते हो कैसा भी, ठीक है, and then check its circuit rank, and then after remove these edges. Clear? From this graph you can start with any simple graph. ठीक है, कोई एक simple graph से आप start कर सकते हो. ठीक है, that includes some more vertex and more edges. That is one of the complex form. But if you start with this square also, okay, that is a square here, and now I have to create one of the circuit, one of the tree from this graph. So let's check first its circuit rank. So that is a m minus n plus 1. M is equal to 4 here. N is equal to also 4 and plus 1. So answer is equal to that is a 1. Okay, means you have to delete only one edges. तो कोई भी एक edge delete कर दो इसमें से. ठीक है, let's remove it. That is a tree. ठीक है, you can also delete this left hand side edges, right hand side edges. Okay, you can delete any edges, single edges you have to delete. ठीक है, but if you had remove one more edges, suppose कि आपने ये भी delete कर दी, so now this graph disconnected. You just remove this circuit rank answer only. Okay, that answer only you have to remove this number of edges. Clear? So that is you can start with this any simple example. If it is difficult to understand for this graph, if it is include some more vertex, just start with the simple graph. Okay, and then first understand the procedure. Clear? What is meaning of this formula? How we can use it for any graph to make as a tree. Okay, and then after try it for this all the graph. Clear? How we can create a tree from this any given graph. Okay. And here it is one more result. A spanning tree is a graph. It is a subgraph that contain all the vertex, and it is a tree. And graph may have many spanning tree, as you can see in this graph. That is a shape of K4. Okay, what is this shape? That is a graph of K4. 4 vertex, and all the vertex are connected to each other. Okay, that is shape of K4. Clear? And we can create many spanning tree of the K4. Clear? Let's first check a circuit rank of this. That is 6 edges, m minus n plus 1, 6 minus 4 plus 1, and that is equal to 6 edges है. ठीक है? Total number of edges are 6, 4 vertex है. So 6 minus 4 plus 1 is equal to 3. Okay. So you have to delete at least 3 edges. Okay, you have to delete 3 edges to make this graph as a tree. आपको कितनी delete करनी है? 3 edges to make this graph as a tree. So these are the possible answer. Okay, of spanning tree. That is the first one. Which edges you delete? this both left hand side, okay, both side edges, and here remove one of this cross. Okay, so now this graph is look like this. All the 4 vertex are as it is that, and 3 edges you have to delete. Okay, remaining 3 edges as it is. That is another solution. Okay, you can consider this graph also, you can consider this graph, and you can also consider this. Clear? And these are the all possible solutions. Total, you can create 16 spanning tree for any for this complete graph K4. These are the all possible spanning tree of the K4. Okay, all the possible spanning tree of the K4. Okay, the first graph, second, third, and fourth, and then after you consider this step. Okay, then after that is 4 possibility, and these are the 4 possibility. Okay, total 16 spanning tree you can create in this K4. Clear? As an answer, you can use any one. Okay, as an answer, you can use any one, any spanning tree you can consider. Clear? So we have one formula for the complete graph. Okay, for any complete graph Kn. Okay, any complete graph Kn. K2, K3, K4, K5, K6, any complete graph you can consider. So you can create number of spanning tree. Number of spanning tree. That is n raised to n minus 2. Okay, that is one of the formula, and you can use this formula to check how many spanning tree we can create for complete graph Kn only. Okay, this formula is not applicable for any graph. That you can use for a complete graph part. Okay, if it is a K9, K5, K7, K11, then you can use this formula to check how many different spanning tree we can create. Okay, so here it is a K4 graph is that. Okay, so let's use this formula to verify the answer. These are the 16 answer we have. So n is equal to 4, that to 4 raised to 4 minus 2. Okay, 4 is the base with the power 4 minus 2. So it is equal to 2. Okay, and 4 square is equal to the 60. Clear? So these are the 16 answer of the K4. Clear? If it is a K5 is there, okay, and it is asked for a 1 mark short question, otherwise 1 mark MCQ. How many spanning tree you can create in K5 graph? Clear? So at a time you have to not draw all the possible spanning tree, and it will take lots of time to manage all such possibilities. Clear? So this is one of the simple formula, you can use it to check the answer. It is always n raised to n minus 2. Okay, is it clear? When we can use this formula, it is for 1 mark short question, otherwise 1 mark MC. Clear? A K5 graph is that complete graph K5. So how many spanning tree you can create in K5? So it is a 5 raised to 5 minus 2. Okay, 5 with the power 5 minus 2 means 3, and 5 cube. That is your answer. Clear? Similarly, you can create for K7, K9, K11, and so on. But we cannot use this formula for K23 graph. There is another formula for K23 graph. Okay, that is a complete bipartite graph. It is a K35 graph. That we'll discuss in the lab sessions. Okay, how many spanning tree we can create in this complete bipartite graph. Clear? Formula is used only for a complete graph, n raised to n minus 2. Clear? So these are the 16 various answer of its spanning tree. Clear? 3 edges delete करनी है आपको, ठीक है? And you can change the possibility of the edges. ठीक है? In the first case, we consider the 2 inside edges and one of the boundary. ठीक है? So we'll get this 4 possibility. In the first 4 graph, we just remove the cross. ठीक है? दोनों edge हमने remove कर दी, and one of the boundary edge, and then you will get this set. ठीक है? In the second 4 cases, we just remove all the 3 boundary edges. ठीक है? Cross as it is that all the 3 boundary edges. ठीक है? Boundary की तीनों edge delete कर दो आप. You will get this type of shape, and that is not a close. Okay, this shape is not a close. Okay, that is one of the cross here. There is no any vertex at that cross. Here 2 edges are cross, means there is no intersect there. Clear? Here it is not a vertex. If it is a vertex here, then it is a close. This triangle is create one of the cycle. Clear? But this is not a triangle here. Okay, that is open. these 4 vertex are open. So these are the 4 possibilities. And in third case, consider one of the inside edge and 2 from the boundary edge. Okay? Consider 1 as the inside and 2 from the boundary. So that you will get this set. Clear? And in this case, you consider 2 from the boundary, okay, and 1 from the inside. So we'll get this type of set. Clear? That is 4 possibilities. So is there any confusion in a spanning tree? Is there any doubt to anyone? Okay. We just practice some more example. Okay. It's very easy, not a difficult. How you can create a spanning tree. Clear? Now we consider next topic, a minimum weighted spanning tree. Okay. Minimum weighted spanning tree. So what is meaning of minimum weighted spanning tree? Okay, in this spanning tree graph, okay, in any simple graph, we have the normal edges. Okay, there is no any such direction is mentioned that. Okay, no any such weight is mentioned there. Clear? And we just remove any edges to create such graph. Okay, in this case, for graph, there are 16 possible answer we have. Clear? 16 answer we have. We can use any answer as a solution. Clear? We just remove any edges. Okay, any 3 edges we can remove it and we get one of the graph. Clear? There are 16 answer we have. But in minimum weighted spanning tree, what data we have to focus that? We just consider such edges whose weight is minimum. Okay, what is meaning of weight? If you consider two any places, okay, then distance between two places, okay, let's take it is a 5 kilometers, then another 2 places that is a 6 kilometer, another 2 places that is a 9 kilometer, and so on. Okay, so this weight, okay, this distance meaning that is the weight of this edge, okay, weight of this network. So we just consider such edges whose weight is minimum. Okay, we consider such graph, okay, of the tree, and we involve such edges in such graph of tree whose weight is minimum. Okay, and that graph is known as a minimum weighted spanning tree. Okay, we'll consider a spanning tree only, but we'll involve such edges in this graph whose weight is minimum. Okay, so that only a unique graph you will get. Okay, there are not a multiple possibility you will consider. Clear? That is always a unique graph of minimum weighted spanning tree. जिसमें आपको ऐसी एज इन्वॉल्व करनी है कि जिसका वेट मिनिमम हो कंपैरिजन टू अदर. ठीक है? So let's first check the definition and then after we'll discuss it. Example. What is the definition? A tree is said to be the minimum weighted spanning tree of a graph G. Tree is said to be the minimum weighted spanning tree of the graph G if T is a subgraph of connected graph G which connect all the vertex together. That is definition of spanning tree. Okay, T connect all the vertex, okay, and it is subgraph of the main graph. That is definition of spanning tree. But now we add one more conditions to say it is a minimum weighted spanning tree. Which condition? Without any cycle and minimum possible total edge weight. Minimum possible total edge weight. Okay, minimum possible total edge means we involve such edges whose weight is minimum, and then after we'll find it total. Okay, total weight 6 kilometer plus 5 kilometer plus 3 kilometer plus 2 kilometer, जो भी उसका weight है, when we total it, and that should be the minimum. Okay, and then we can say that this edge has a minimum weight. Okay, we consider such edges in the spanning tree whose weight is minimum. Okay, and therefore we'll get it total is also minimum. Okay, so here we consider minimum possible total edge weight. Okay, and that is a spanning tree whose sum of edge weight is as small as possible. Okay, and then T is known as the minimum weighted spanning tree. Okay, we consider such edges. Okay, we connect all the vertex, will include all the vertex of the graph, and then after we'll connect this, okay, by the edges which is given in the graph G, and we consider such edges whose weight is minimum. Okay, हमें ऐसी एज कंसिडर करनी है ट्री में कि जिसका वेट मिनिमम हो. Okay, we'll connect these two vertex whose weight is minimum. Okay, we'll consider minimum weight first and then after we'll connect. Clear? So here I think this graph is not visible. Let's draw it again by another color. Okay, there is one vertex here. Yeah, is red color is visible to all? Red color is visible? Yellow. Yeah, now okay. These are the vertex, okay? And now I mention the weight of these edges. Clear? There is a edge between these two vertex whose weight is a 4. Okay? That is a 4. There is a connection between edges whose weight is a 4. Okay? Weight may be anyone. You can consider as any form. Clear? That may be kilometer between these two objects. Okay? Distance between any two objects. Clear? Any data you can consider in place of that. So 4 means a distance between these two places. Okay? Then after these two edges are also connected and whose weight is a 14. यहाँ पे है 14. ठीक है? Then after these two are connected whose weight is a 6. इसका distance है 6 meter or 6 kilometer. Then after these two edges has a 11. Okay? That is 11. Then after this has a 13. Okay? This has a 8. These are also connected. It is also weight 8. This is a 10. It has a 5. That is a 12. And it is a 70. Okay, so this graph is given. This includes some circuit, okay, closed walk, and now we have to consider this graph as a tree. Okay, we have to create one tree by using this graph. Okay, and that is known as a spanning tree. So first we apply the concept of spanning tree. Okay, how we can create a spanning tree from any graph. So first we'll check a circuit rank. Okay, first we'll check a circuit rank, and based on that we'll get idea how many edges you have to delete. Okay, so how many edges in this graph? Number of edges, that is 4, 7 vertex are there. N is equal to 7 and edges is equal to 4, 5, 6, 7, 8, 9, 10, 11. 11 is correct. Okay, so m minus n plus 1, that is equal to 11 minus 7 plus 1. And what is answer? 5. Okay, so what is meaning of the 5? You have to delete a 5 edges. ठीक है, आपको 5 एजेस में से निकालनी, बट कोई भी नहीं. ठीक है, let's consider which edges you have to consider. So let us first create the graph again. Place the number of vertex as it is as per the given. Okay, these are the 7 vertex given. Okay, and now we connect first such two vertex. ऐसे दो वर्टेक्स को पहले कनेक्ट करना है जिसका वेट मिनिमम हो, जिसका एज वेट मिनिमम. ओके, तो व्हाट इज द मिनिमम वेट इन दिस ग्राफ? 4 इज द मिनिमम. ठीक है, तो पहले उस दोनों को कनेक्ट करना है. ठीक है, विल स्टार्ट विद द मिनिमम पॉसिबिलिटी ऑफ द वेट. क्लियर? विल स्टार्ट विद द मिनिमम पॉसिबिलिटी ऑफ द वेट. क्लियर? सो फर्स्ट कनेक्ट दिस टू वर्टेक्स. 4 is the minimum weight, so first connect this two vertex. Okay, this edge will consider in our tree. This weight is a minimum. Okay, now next weight after 4, that is a 5. Okay, that is in between this upper two vertex, so connect this two vertex. This is a weight of 5. Okay, minimum is a 4, so first we'll use this edges. Okay, after 4, that is the next is a 5 is the minimum. Okay, so connect this two vertex, and after 5, 6 is that. Clear? And you have to observe that you cannot create such type of cycle. Clear? If it create a cycle, then you just remove these edges. After 6, which is minimum? That is a 8. Okay. And there are two edges whose weight is a 8. Okay, so connect both. That is a 8, and that is also has a weight 8. Okay, this both has weight 8. यहाँ पे दोनों का weight क्या है? Same. ठीक है, and still my graph has no any cycle. Okay, up to this, how many edges I have include? 1, 2, 3, 4, 5. I consider 5 edges, and still this graph is a has no any cycle. Okay, Now after 8, that is a 10, okay? But if I consider the 10, if I consider 10 here, okay? If I connect this vertex, that is weight 10, so it create one triangle between these three vertex and it create one of the cycle. So I cannot consider this edge in my graph because my requirement is I need one tree and tree does not contain any type of cycle. Okay? That is weight is a minimum comparison to the 12, 17, 11 and 14 so on. This weight is minimum comparison to this forward, but I cannot include it in my graph. Okay, because it create one of the circuit by using these three vertex. Clear? So just skip this edge. इसको आपको skip करना, ठीक है यहाँ से. Now after 10, which is minimum, that is 11. Okay, and if we connect this edge whose weight is 11, still the graph is has no any cycle. Okay, you can see it. There is no any cycle between any two vertex. Clear? Now after 11, 12. If you consider the 12, okay, here, that is a 12 are in between these two vertex. Clear? So if you connect it here, it create one triangle and that create one of the cycle. Clear? So I cannot consider 12. Then after 12, after 14, so 13. If I connect this 13 in between these two vertex, it create one triangle. Okay, that one of the circuit. And then after 14, if I connect this edge here, 14, then it is also create one of the triangle. Clear? And that's 17. If I connect this edge here, then it is also create one of the cycle. Clear? So I cannot include the remaining edges. Clear? Because it follow one of the cycle. That is this one. Okay. यहाँ पे एक cycle create होगी. Let's check it. This edge 13, 17, okay, 14, and then after 12. That create one of the cycle. Clear? If I use it in my graph. Okay. So that is my minimum weighted spanning tree. Clear? That is my minimum weighted spanning tree. All the vertex are included. All the vertex are included. Okay. It is connected. All the vertex are connected. There is no any single disconnected vertex is there. And there is no any cycle are defined. Clear? Between any two vertex. Clear? So that is called spanning tree. And in this spanning tree, we have included such edges whose weight is minimum. Okay? In such spanning tree, we have included such edges whose weight is minimum. So therefore, this graph is called minimum weighted spanning tree. Okay? This graph is known as a minimum weighted spanning tree. Is it clear? Any confusion? Okay, first observe this graph. Okay, weight is mentioned in all the edges there. Clear? And then after mention the number of vertex as it is here. Okay, and then after start with minimum weight edge. वहां से आपको start करना है. ठीक है? पहले उन दो vertex connect करना है. Clear? Then after next weight is take from the graph. Okay, then use it another weight and verify your graph. Okay, observe your graph after connecting these edges. Okay, can we create any cycle or not? If it is create any cycle, then skip this edge. Okay, skip this edge and focus to the next weight. Clear? यहाँ पे देखो, here when we consider this edge, okay, after 8 we have 10 is the minimum. Okay, so if we connect this edge here, so it create one cycle. So therefore you have to skip this weight. Okay, and we focus to the next weight. Next weight is 11. 11 ने हमने यहाँ पे use किया. Okay, because that graph does not contain any type of cycle. When we consider these two edges connection. Clear? So that is called minimum weighted spanning tree. Clear? And now here we need a total. So just check the total of the whole weight. Clear? Total weight. Clear? Here you have to check that minimum possible total weight. So what is the total weight? That is equal to 4 plus 5 plus 6 plus 8 plus 8 and plus 11. Okay. So what is the total? 40. 42. So 42 is your answer. Okay, that is mean. So first we'll, as we know that what is the circuit rank of this graph? It is a 3. Okay, so just create this graph. That is a 3 is the, okay. So what is the minimum weight? Is a 1. Okay, so connect first these two vertex. Clear? Now what is the next weight? 2. So connect this two vertex 2. Clear? That is a 1. That is a 2. Now what is the next? That is a 3. So connect this one. That is a, clear? That is the answer of this. Okay, that is the minimum weighted spanning tree. Huh? Perfect means but if we change this weight, then it will be different one. And that will get unique answer. Okay. If we compare the spanning tree and minimal weighted spanning tree, in spanning tree we have K4 answer. There are 16 various graph of the spanning tree. Okay, of K4. But if we include such weight to the K4, okay, here it is weight is included to the edges. So we'll get a unique graph only. We cannot find multiple answer of minimum weighted spanning tree. Clear? That is unique answer, which include these 3 edges as per the given. Clear? If we compare spanning tree and minimum weighted spanning tree, clear? In spanning tree, we can find multiple possibility of the answer. But in minimum weighted spanning tree, when edge weight is count, clear, as a minimum form, then we can find only unique answer. Okay? We can find only unique answer. Is it clear? Any confusion? Yes. બધા vertex. એવું પોસિબલ જ નથી કે જ્યાં બધું સરખું હોય. ના આપ્યા હોય, ઇઝ નોટ પોસિબલ. Okay. We'll practice some more after that. That is Kruskal algorithm. It is similar to the minimum weighted spanning tree. Okay. In Kruskal algorithm, that is one of the algorithm to find minimum weighted spanning tree. Okay. That is C programming is also available of this program. You can use it, this C programming, and then after enter the graph data, and then you can get direct answer. Okay. That is one of the algorithm you will learn, I think, in DS, otherwise DMS and so on. Okay, but you will learn this program of this one in DS, I think. Okay? So let's check how we can use it for any graph. Okay, without C programming, how we can find the answer? Clear? Okay, which data we consider first? That is similar to the minimum weighted spanning tree, but that is one of the collections we have to create that and then after we have to arrange this number of edges. Clear? So that is one of the graph is that, okay, which include 9 vertex and this number of edges. Clear? That is visible, this data. Okay, weight is mentioned. Clear? That is 6, 3, 4, 3, 10, and so on. And now you have to create one of the spanning tree of that one, which is known as a minimum weighted spanning tree. Okay, by using the Kruskal algorithm. So that is a separate questions will be there in the exam. Derive the minimum weighted spanning tree by using Kruskal algorithm. Okay, if it is offline exam, then the one of the separate questions will be there. Derive the minimum weighted spanning tree by using Kruskal algorithm of the following graph. Okay, one of the graph will be there as per the given. So, what is the first step in this Kruskal algorithm? Clear? You have to just observe all the edges and make one collection of all the edges. Clear? That is the graph is there we have, and these are the all the edges. That is A to B. That is the distance is of 4. So you have to consider this A to B, B to C, B to J, C to F, D to J. Okay, as per the notation. This notation is ABCD is there. So here we mention ABCD and so on. Clear? That are the collection of all the edges. Okay, which include all the weight in of the graph. That is a step 1 in Kruskal algorithm. Okay, and after in next step, sort the edges. Okay, that is the next step. In reality, they are placed in priority queue, not sorted, but sorting from makes that algorithm easier to visualize. Okay, sorting the edges means we'll focus first minimum weight. Okay, we'll connect it, and then after continue this queue. Okay, continue this chain. Clear? To connect all the remaining vertices. So now we have to sorting these edges. We'll focus first minimum weight. Clear to this graph. What is the minimum weight that is the A to D? Clear? Yeah. Yes. You just yeah. These are the collections we have. Okay. As per the graph, and then after we sorting is as per the queue. Okay. If you see it here, we collect the edges of the sequence such a way that whose weight is increasing form. Okay. A to D, that is a 1 weight, then after 2, 3, 4, and so on. Okay, this is known as a sorting. Is it clear? In the next previous slide, we have all the collection of the edges. These are the collections as per the graph. Okay, randomly you have to put any edge, and then after sorting it, what is meaning of sorting? You have to just arrange this all the edges in sequence. Okay, arrange all the edges in sequence. That are the sequence of the weight. Okay, and then after we'll start the first connection. That is in between A to D. That is weight is a 1. Okay, next weight, that is a 2. Clear? So connect the second edge. That is in between. Sorry, 1 is also there. In between C to F. Okay. So connect, include these 2 edges in your graph, whose weight is minimum is 1. Okay. So we include this here. That are reflect here also. Clear? In both the places, because we include this edge in our graph. Then after next, weight is a 2. So these are in between C to E and E to G. Okay, this both has weight 2, and still your graph has no any cycle. Okay, up to this stage. After next step, weight is a 3. Okay, so if we include this edge, which is in between C to F, if we included here, sorry, C F to G, if we included here, it create one block. Okay, which create one cycle. Which cycle? This 3 we have already included. C to F to C, then after C to E and E to G. This already we consider in our graph. But when we consider this edge also, which weight is minimum, okay, comparison to the 4, 6, 5, and so on. But we cannot include in our graph. Okay, we cannot include in our graph because it creates one of the close walk by using this 4 vertex. Okay, so therefore we'll skip this edge. Okay, the next weight is also 3, that is in between G to I. Okay, and that we can include in our graph. Okay, that not create any type of cycle between any 2 vertex. Here still your graph is open. There is no any closed work is created when we include this weight. Clear? But if we include this weight, that create one of the block. Clear? Then after I to j, okay, that is also weight 3. Yeah, this one. Okay, I to j we connect. So still graph has no any cycle between any two vertices. Clear? And this is a minimum possible total weight. After 3, weight is a 4. Okay, and that is in between A to B. Consider the weight in between A to B as a 4. We connect these edges, still graph has no any cycle. Okay, all the vertex are not connected, but still graph has no any cycle. Okay, now after 4, weight is a 5. Clear? So if we weight is a 4. So if we connect this B and D here, okay, that is mentioned by reading B and D. So here we create one cycle by using these 3 vertex. So we cannot include this weight in our graph. Okay, we cannot include this edge in our graph. Is it clear? So therefore it is blink as a red color. After this edge, there is B and C has also the 4. Okay, B and C this way. That is a B and C. It is also 4, and still graph has no any cycle. Clear? Graph has a no any cycle, and all the vertex are connected now. Okay. So rest of the edges you cannot include in your graph. Okay. If you include this edge G and J, that is a G and J. Okay, this one. If you connect it here, it create one of the block triangle. Okay, that follow one circuit. F to I. F to I. If you consider it here, this edge that create one of the circuit. Then after D with J, D with J, yeah, this one. If you create it here, that create one of the triangle. Yes. Ha. But this type of situations will be not there. Okay, as you can see it here, if we map this situation to the, any of the real life, okay, any of the real life situation where you have to consider one of the minimum weighted spanning tree. Okay, minimum weighted spanning tree matlab kya, that will discuss later. If you consider this graph as a minimum weighted spanning tree, and now you have to find such walk, clear, find such open walk. Okay, from this any of the place, okay, any of the place you have to reach to any of the ending place, the distance should be minimum. Okay, suppose कि आप यहाँ पे है and you have to reach to the B. ठीक है, आपको B तक पहुंचना है, तो which route you have to follow? ठीक है, कौन सा रूट आप फॉलो करेंगे that get minimum distance? Clear? That get minimum distance. And here you can see that B and C are near. Okay, and B and J has a maximum distance, so that not always a 4 there. Clear? So that is the purpose of minimum weighted spanning tree. By using this minimum weighted spanning tree, we can find the minimum distance between any two places. Clear? And the minimum distance between any two places by using this answer, by using this graph. Clear? Using this graph. And you can verify also that suppose कि आप यहाँ पे हो at the place J and you have to reach to the D. Okay, you have to reach to the B, you have to reach to the C, okay, and so on. So which possible route is we can consider, which we can use it for any two places, and which is a minimum weight, clear, minimum distance, clear. So that is applications of minimum weighted spanning tree. We can find the minimum distance between this any two places, and that is your graph. Okay, that is a graph is given, and that is it minimum weighted spanning tree. Okay, and we'll practice some more graph. Okay, in the next lecture. That is these two graphs is given here. Okay, we'll practice some more graph in the next lecture. We'll keep up to this in today's lecture. Okay, so today we discuss concept of spanning tree and minimal spanning tree. Okay, concept of spanning tree and minimal spanning tree for any of your graph. Okay, in the spanning tree we consider one of any graph and we can create multiple answer. But in minimal weighted spanning tree we can create only a unique answer. Okay, as per the weight you have to arrange the edges. Okay, we can include the edges in a graph. Clear? And that graph look like a minimum weighted spanning tree.